how do we deal with inequalities that have absolute values in them? That's what this question is talking about. And here's your inequality right there. And I have to figure out which one of these three graphs, or there might be more than one, which of these graphs correspond to the solution set of this inequality. Now, the quick answer is, it's actually quick. This one's very easy because if you think about what an absolute value is, this has got to be some positive number, right? I have no idea what x is. But if I take the absolute value of x minus 4, it has to be positive. And look what this thing's saying. It's saying a positive is less than a negative. What this translates to in math speak is hot garbage. That's never going to happen. Positives can't be less than negative. So this is basically a DNE problem. Does not exist. This is none of the above. So let's change this now and talk about something a little more interesting. There's a bunch of varieties. There's a bunch of versions of this problem that you might get. Let's say you got something that looked more reasonable and interesting. X minus 4, absolute value, is less than positive 2. How do we deal with that? Well, now it's a much more challenging problem. And what I want to do, when we solve, let's talk about it this way. When you solve an absolute value equation with an equal sign, you have to solve the positive case and the negative case. Well, that's true here too. First, I'm going to say x minus 4 is less than 2. And then I do another inequality where x minus 4 is compared to negative 2. Except what's weird is the less than sign flips over. It's one of those strange things that inequalities do around negatives. When I change that 2 to a negative 2, the sign flips over. So now I have two equations, and I'm going to solve these in place of the absolute value inequality. All right, so I'll just number these so we can keep track of them. And let's work them down here. X minus 4 less than 2, well, that means x is less than 6. And the second one, x minus 4 greater than negative 2, that means x greater than positive 2. So we have our answer. It's this version right here, the one that exists between 2 and 6. Now, if you're not fond of that whole algebra thing that I just did right there, and I have a feeling which one might bug you if something bugs you here, it's this idea of creating two equations out of one, or two inequalities out of one inequality, and then switching the signs on it. Right, it's kind of some weird algebra going on. So let's talk about a graphical way to think about this instead. If you prefer graphical solutions, this might appeal to you. X minus 4, you can think of that as having, an x-intercept. What if you plug in 4 into that inequality right here? And you say that's 4 minus 4. Well, the absolute value of 4 minus 4 is 0. Is that less than 2? Sure is. Okay, so that works. And plug in some other numbers. And you can plug in numbers all over the place, and you can figure out which ones work and which ones do not work with this inequality. So that's the plug and chug method. And in some ways, that is actually quite nice. Another thing you can do is think about how far from 4 we're getting. What this means right here, this is a difference. It's the difference between x and the number 4. Okay, so it's difference between x and 4. And we're saying is that difference can't be bigger than 2, meaning you've got 2 in this direction that you can go and 2 in that direction you can go, and that's it. Can't go any farther than that. So there's 3 methods. I like the one where you just plug in numbers and check them. The graphical one appeals to me too, but if you like, you can try the algebra method where you create 2 equations out of your absolute value inequality.